So let's get back to what you did this morning. I think for many of you, it's the first day you used Jupyter Notebook. So the way it works at the basic level, if you are at your command line, you will create. Oh yes, sorry. You will enter the command Jupyter Notebook, and what this does is on your machine it will start a web server, and this is what you access in your browser. You basically have a local web server that serves all this file and allow you to interact with them. You have many options when you go to this UI. Of course, you can navigate your file system. And you have this new button here that allows you to either create text files, folders, and terminals. This is mostly because here in this session we are doing that on your own machine, but you can do that on your lab by deploying that on a cluster or on a server, and you can access it remotely. And when you do that, it's really important that you set a password and you look at the documentation. There are also some limitations where you are in this environment. We are in the browser. So there are some things we cannot do in the browser, that some keyboard shortcuts that you might have seen don't work as well as in native application. One of the basic things you can do is create notebook. So to do that, you can use new, and you have a notebook section. Here you see that I have a lot of choice available. You might have one, maybe two. But the Jupyter Notebook works in general with more language than just Python. And you see, for example, that I have kernels that are explicitly broken because I'm on a development environment. And you can basically say, hey, I want to create this file using Python 2, or I want to create this file using Python 3, or I want to create this file using the Julia language. You can change that afterward. And in some setup, for example, if you have a cluster, you can decide that this is actually a specific machine. So you can say, hey, I want to run this notebook on a machine that have 6 terabytes of RAM and 24 gigabyte GPU. But you can also create a normal text file. You have this text file editor. And if you just rename it to foo.py, it should automatically have a syntax highlighter. Syntax highlighting, say hi, and name. And you can say print hi space plus name. It's really important, even if at the beginning you like the notebook, or maybe you don't like it, to understand that each task might need a different file format. So it's not because we show you things in Notebook that you have to use Notebook all the time. Notebook are great for certain things, but at some point you might want to go back to a normal text file because, for example, you want to share your code and make a library. So even if I show you a lot of things in a notebook, don't forget that you have to use the right tool for the right task.
Sorry. I didn't read the green, the blue, and the red, and the formatting. Is that common?
So that's syntax highlighting. You can change your theme. This is a theme we use in general in the notebook. I don't think we have the ability to change it here. But if I, for example, use Vim, yes, I will make that bigger. If I do def, I haven't saved it as a py file, so here it say, I don't know what def is. Def, say hi, name, pass.
I just realized that in Jupyter, you have yours as Python on the top right.
Yes.
And I had it as plain text. I could change that inside of line.
Okay, so here, because I named the file py, it automatically detected, hey, this is Python. I'm going to highlight it as Python. I'm pretty sure if I change it to, TXT, yeah, TXT will have no highlighting. And if I use sh, it will probably say, hey, this is a shell file. I can actually use bash, and it will try to get the right highlighting, etc. So let's click back on the Jupyter logo. I will get back to the dashboard. It won't save, and I will go to lecture and 4. And you can follow through by looking at Notebook Basic and IPython beyond plain Python. But I will try to do it from scratch. So what we can do is create a new notebook. So to do that, we will go to New and New Notebook. And here you have two things that happen at the same time. You have a new document which is created, which will hold all your narration and your code, and you will have a kernel that's starting in the back. The kernel is a Python process that will execute all your code. It implies that there are some confusion that can happen when you write code and you iterate over it. And you start with what we call a code cell in which, yes?
Sorry, I tried to open up one of the notebooks that have been basically done to the schedule, and it was for the breakout session, and instead of having to click on the kernel on the right-hand side, it just has an error message saying none not found. It won't actually execute any of the functions that I'm writing.
So try to do the following. Try to do kernel, change kernel 1, then you save your file and you reload your page. This is a bug we are aware of. We learned about it yesterday. And it's because you've used Anaconda. There is some weirdish things that should be fixed in the next few weeks. But we can force a kernel change after a while. So some people might have a bug when they open notebook from the lecture because of some change that happened on Anaconda, not just recently. So this is a code cell. Oops, sorry. You can write code in your code cell, like as you've seen before. You can say print hi Berkeley. And you can run this cell. So you have two ways of running this cell. One is to click the run button, which is here in the toolbar. But it's quite painful to do it every way to reach for the mouse. And so we have shortcuts. We have keyboard shortcuts for that. You've seen one keyboard shortcut this morning. If you press Shift, so here I'm pressing Shift on my keyboard and I press Return or Enter, it re-executed. I can say, hi everyone, and press Shift Enter, and you saw that it's changed. There are many keyboard shortcuts available. One of the things that you might want to do at some point is go to Help and see keyboard shortcuts. And the keyboard shortcut will remind you, like on OS X, you will have these reminders. These symbols mean these modifiers. And you see that you will have a long list of things that you can do only from the keyboard. I highly recommend you learn some of the basic keyboard shortcuts because they will allow you to be much quicker in your iteration process. Yes?
Sorry, I missed when you went from a Python file to the interpreter. How did you go from one to the other?
How did I went from from basically this to this? So when I'm here, usually in all the pages, you have the Jupyter logo on the upper left side. And if you click there, it brings you back to your home directory and to your home where the server has been started. And then either you can find a notebook, which is an already existing notebook, like lecture 4. And here you see that there is a green one. This green one means this one is already running. It's already there. It's already somewhere. And actually, it's there. And I can, for example, say, hey, can I see the notebook basics? And it opens and I see it by clicking. And I can close it. Or I can just make new and choose in which language I want to do my notebook. Right? And here you can have many Python 3. You can have a Python 3 environment if you're using environment. One where, for example, there is some library which is not installed so that you can test your code with NumPy not installed, for example, and make sure it works. Or have the version 3 of something, or the version 2 on something. This is advanced usage. For now, you have one kernel. It's more than enough. And this code cell has a value on the side here that you can see, which here is 3. It means this execution is a third execution I did, which means that, for example, if I do a = 1, it will say 4. And I can say, for example, oh, actually, I want to do something before that. I can add a new cell and say print a. And then you have the prompt number, which is 5. And here you see that my execution was out of order. It's really useful because when you want to iterate over a script and you have a huge data set that you have loaded, it can take a few seconds, so you don't want to rerun everything from scratch. And these numbers on the side are here to remind you what you did and when. And now what you can decide, for example, is to rerun everything, which is really interesting when you want to make sure you have your code correct. And to do that, I will do, for example, kernel restart. So now I'm killing the process that ran my Python. I restart the kernel, you will see that the dot here will become black for a few seconds. And it was too fast. You probably haven't seen that on the projector because the projector is slow. And now I have a kernel which is clean from any execution. And I can also access my document, which stores everything you see here. And I can clear it. So I can do cell, all output, and clear. And you see that it removed hi everyone and print 1. And now if I do cell, run all, it will rerun everything in order to make sure that I have all my steps right. And actually, yes, my steps were wrong because I printed A before defining A. And so one of the things I can do is to actually click on this cell and move it down. And now my steps are again in the correct order, and I can rerun all my analysis and make sure it's correct. So just to go slightly more into the interface, you can see on the side of my cell here that it's either blue or green. This is basically because we have two modes of interacting with the notebook. Either you're in a cell typing something, or you are actually here, I will press KKK and JJJ, and it writes K and J. And if I press escape, I go into command mode, where basically all my keys that I press will have actions on the whole document. So for example, now, J and K move my selection around. There are reasons for that, because you might want for advanced user to select multiple cells and copy and paste around. You can look at the documentation on your own if you want. Another extremely useful feature that you can start to use if you want to take notes is to actually transform a cell to a markdown cell. So you can add a cell by clicking the plus button, and because I've been using the notebook for quite some time now, I know to do it with a keyboard. So when I'm in command mode with the blue line on the side, I know that B for below add a cell below. And now I have a cell below, which is much faster. And you can change this code cell to something that we will call a markdown cell. If any of you have interacted with GitHub, you know how to write markdown. Who doesn't know how to write markdown here? So a lot of you. So markdown is not a what you see, what you get language, which is a slight compilation that make it display as HTML. So for example, if I want to make a header in markdown, I will do hash, and I will do this is a header. And if I press Shift Enter again, it will render this as a header. And if I want to have a link, we will see you have a markdown reference in other notebook. You can say this is a link, for example, http://www.google.com, close the parentheses, is nice. And if I render this with Shift Enter, now I have a link. And if I click on this link, I will have Google that appears. This is extremely useful if you want to interleave notes with your code. I have a question in the back, yes.
So you can escape into this mode where you can use the keyboard shortcuts. Is there a keyboard shortcut out of it?
So is there a keyboard shortcut out of it? Yes, sorry, I forgot that because I'm used to using that, so I might forget some steps, so feel free to remind me when I do that. So yes, when you're in command mode with the blue line on the side, usually pressing Enter will make you go into edit mode to edit a cell, and it becomes green, and you can also see this small pencil on the side here. And now I can do 12, and I can press Escape, and then I'm back into command mode. If you're a scientist, there is some chance that you might want to write some math. So let's edit this cell and add some math. So here I'm in command mode. I will press Enter. To go to edit mode, I will go to the end of the line. And what you can do is, if some of you are familiar with LaTeX, you can use $, or $, depending on whether you are in inline mode or in display mode, and type something like integral from 0 to infinity of f of x dx. And then you close your mode, you do that, and then you will have your math that display directly inline. So if you're implementing an algorithm, if you have something and you need to have your explanation for you or your coworker, or you in 6 months because you won't remember what you wrote, you can use that to have inline math. And you can also just use it with $1, like for example delta, and do that is the difference. And render, and you will have delta available, and you can use your vectors, your dot, your whatever, whatever you need to render. And so we have these two type of cells that are nice to interleave code. So that's a rough overview of the UI. If you have any questions, feel free to ask. You might see that my UI is slightly different than yours. And when you're doing presentation, what you can do is toggle header and toggle toolbar to have something which has slightly more height. So when we are in a Jupyter notebook and when you have the Python kernel, the Python kernel is not pure Python. There is a small overlay on top of that, which is called IPython, that add some extra syntax and some extra features that make your life easier. It's sometimes hard to distinguish which is pure Python and which is IPython, but syntax which is IPython only might not work in pure Python file if you gave them to someone else. And so you use it with precaution, with great power and great responsibility. And try to be careful about that. But these features make life in an interface like that much better when you are in interactive development mode and when you're exploring data. So if you want to check which version you have of IPython and everything from the UI, one thing you can do is go to About here. And you can see here that the server is running Python 3.5.2, and the kernel is 3.5.2 also. It can be different. And here you see that I'm running IPython 5.2. You might not be. OK. So one of the things that IPython add is a question mark. The question mark character is not valid in Python. And question mark is generally used for help. And so if you just do one question mark and you execute the cell, you will have what comes at the bottom, which is called the pager. The pager is usually used to give information to you. This is not available in plain Python. So everything you see with a question mark, except if it's a string, you won't have in pure Python. And there is a quick reminder of most of the features that you can have in IPython. And for example, we have help and super help. So if you import something, like let's say I want to import collections, and I want to have information on collections. So here I press Enter to have collection in my namespace. I can use either question mark collections or collection question mark, and this will do its best to find as much information you want from collection. And so here I can do that, and I see that collection is a module, and you can see where it is. You can see basically the documentation of that. And you can use two question mark. And two question mark will not only try to find documentation about it, but will try to find the source code. So if you're wondering how is something working, is there a bug, is it me, or is this library author doing something weird, you can use two question mark. And two question mark will here give me all the code of collection we want. We won't read through that. And this is quite easy. And especially if you want help or documentation on a specific object, you can use the full object name and use one or two question mark. And here you will have exactly only for this object the source code if we can find it. So this is quite easy, and again, this is available only in IPython. There are quite a lot of other things that are not valid Python syntax. If you see something that starts with %, it's something which is IPython specific. And basically what it allows you to do is to create some custom functions that do amazing things, magic things. We call those magics. You saw this morning the run, the file, and I don't remember which one. And so quickref will again give you a quick reminder of all the magic syntax you see. You see the object question mark, object double question mark, the % magic, and you have a lot of other things that you can do with double %. The other thing you can do is to use question mark with asterisks or wildcard to look for all objects that you know there are some letters in it, but you're not sure what their name is. If they are in your current namespace, it will try to find it to you. So I know that I have the ability to have an error which was floating something. And here you see floating point error, and I can check, is floating point error here? Yes, it exists. I don't get an error. So, of course, one of the things we have is tab completion. So you probably saw that earlier. I was typing really fast my name tuple things. If you do collections, if I have collections, this is my current namespace, here, COLL, and I press tab, I have only one possibility, which is collection, so it's complete to this. And if, for example, I have color equal 1 in my namespace, and I do call tab, it will tell me which one do you want, and I actually want collection. And again, if you have an object, you usually can do dot and tab, and it will try to fetch as much information as it can. It doesn't always work. So, for example, if I have a list of 1, A, and C, or none, let's do none. And I do L0, which is supposed to be 1, and I do dot tab. Here it will try to find, it cannot inspect the object, so it will try to find a name of the folder that I have here. So if I look at my current directory and I do ls, actually I want to look at everything which is hidden, you see that I have an IPython checkpoint. So when I did dot tab, it matched on that, so it doesn't always make much sense. But if I assign first, and then I do a dot, it's capable of finding what I have here. And we try to do as much as we can for type completion. Another nice feature we have is not tab, but shift tab. So if you want to have some information on the fly on name tuple, and you open a parenthesis, and you're just after the parenthesis, if you press shift tab, we will try to fetch some help. And you can press it several times, like 2 times, and it will have that doesn't go away for a few seconds, so I can type. You see the small clock here, and the small clock will disappear after, I think it's 20 seconds. And now if I type, it will just disappear. And so this is useful if you want to know what a name tuple is and how to use it. You don't have to go press the question mark and get it at the bottom and come back and erase. Okay, so let's see some other nice feature we have. Because we have input number, we also have output number. So here you see that I have output number 17. And one other thing you can do is almost always use the underscore to refer to the previous output. So here underscore means the value of out 17, and it should be 2. So 2 plus 3 should be 5. Yay. That's really useful if you had a really long computation and you forgot to assign it to a variable. You can say, oh my God, I forgot, this is really long. I can basically do, 5 took 20 minutes to compute. Let's do my 5 equal that. And I'm safe, I can access that again. You can also access it directly by number. So if you're using in or out, and you pass the number, let's see if I have one like 10, I should get floating point error. So you can access programmatically what have been done before. And if you want to know what you wrote in, for example, input 16, you can use in and say 16, and you will get what you wrote in the cell 16. And here you see that you got the version that has been automatically transformed by IPython. So here in 16, I actually had the question mark before. This has been transformed by IPython into this function automatically under the hood. So you can inspect how things have been done. And we also have underscore, 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 and triple underscore as a previous result, next to previous result, and next to previous result. Okay. So there is some confusion, often not with text, but when you have graphs about what is to print or to display something and return it. So can you see the difference between this cell and this cell? Oops, this one has an error, of course. So here you will see that the last statement of my cell is something that I can evaluate to 2, and you will have an output result. And here I'm actually printing 1 plus 1. So what I have returned is nothing. Print does not return anything. And this can become a little bit tricky when you have figures that will display none, we'll see later. Sometimes you're making a figure that display and you add some code and the figure does not display anymore. It's because you have to say, hey, explicitly, my figure is not the last thing on my cell. I want, you need to display it,
Sorry, what happened to your input and output 24?
So 24 is still in the kernel side. So the question was, what happened to 24, output 24, for example? So I have executed it. It has been done in the kernel. So I can ask what was my input 24. And it will tell me it was print 1 plus bang, which was a syntax error. But it's not in my document here, because I decided I didn't need it and I want to get rid of it.
So when you edited it and then reran it, it disappeared off your screen. But
Yes.
the one that you ended up keeping is now known as 25.
So yes, when edited, when I have an input like wrong input, wrong input. Oh, I don't know what this is. Oh, actually, I want a comment. I comment that, and the wrong input without the hash is discarded from the document, and this one is replacing it. And you basically see that I have a gap in my document. So it's a good practice to try to get something to work and say, oh, actually now I want to restart my kernel to forget all the thing I made and to rerun everything from scratch. Because, for example, as I showed before, you can say a equal 1, print 1, and this, oh no, print a, and it still knows that a is 1 because you have the two processes. It takes some time to get used to it, but you will see that after a few days it makes complete sense, and you start to figure out when and where are things. We also allow you. Question? No. Okay. Yes. No. So is there a way to see all the variables in your namespace? Yes, there is a Python way and there is an IPython way. The Python way is to look at the dictionary called globals, which show you everything that exists. Usually you don't want to deal with that. There is also locals, but this is Python usage. We provide who and who ls. So if you do %who, it tells you everything which is currently available in your namespace, excluding everything which is specific to IPython. And if you do who ls, it will try to pull to make it as a list so that you can interact with it. There are also who's that give you even more info and try to find the size of variables. So if you have a huge array and your computer is slow, say, oh, maybe I have something which is really huge. Here. And again, because it's starting with a %, it's just IPython syntax. It's just syntactic sugar for making things easy. One of the other things that you showed, that I showed you, which make things easy, is you can directly use some shell command directly in your Python. This is completely not valid, but if I do ls, it does list my file. And one of the things we add, this is actually syntactic sugar for bang, ls. Which is even more syntactic sugar for something else, which means that if I want to find all my IPyNB file, I can do star.ipynb and execute, and I have only my IPyNB files, and I can do files equal, and this is not valid Python. And now what files is a list of all my files. So if you don't know how to do that in Python, you can do it quickly in IPython and figure out how to do it in Python. Technically, if you want to do it in pure Python, you will have to use the glob module, import the glob module, and do glob with a string of your regular expression. But that's not the thing we want to do now. The other things you can do now that we've seen the bang is to actually shell out to subcommand if you have some bash script or some Perl script and pass them some value. So for example, here, if I want to echo, for example, the second notebook name, I should be able to use curly brackets and do files1, and this should echo exercise at IPyNB. And so you can decide that you have some analysis script that need to be run from inside Python. And in a notebook, then you can shell out to something and come back to your workflow without having to switch tool, which is extremely useful. So we saw that a single percent is not valid Python, so we can use double percent for even longer things. One of the usage that you've seen is Timeit. So Timeit is either with 1 or 2%, and with 2%, it basically allows you to time a block of code. So if you're doing optimization and you want to get a quick analysis of if something is fast or slow, you can, for example, define Fibonacci of n, and if n lower than 2, return 1, else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Is there a mistake here? I don't know. And I can check Fibonacci of 4, and it will, yep, I need a colon here and do that. And here it will run it a few thousand times in the back and tell me how much it took. And it took 1.46 microseconds per loop. I probably won't do much bigger than 4 because I know that this version is using an exponential time. And I have a question in the back.
Sorry, you mentioned that a single percent sign is not valid Python code?
Yes, a single percent sign is not valid Python code when it's at the beginning of a line because a single percent sign is also the modulo operator.
And you could run a single percent sign if you were just referencing one of the magics.
Yes, so basically, we won't see how to register a magic, but if you do percent something, this is some syntactic sugar for calling the function something, which what's after. But the advantage of that is that after a percent sign something, you can put non-valid Python syntax. So for example, I don't know if I have time to show that here, but you can inline R code in the middle of your notebook. And so you could have something like %% R, and I want to send in the value of X and the value of Y, and I want to get out the value of LM model. And I can say, for example, I want to have LM model, which is my linear regression model of X versus Y. Here it won't work because I don't have the right library installed here, but because you have a percent or a percent is just for a single line, a percent is for a whole cell. I can have in the middle of my notebook some syntax which is not Python and that will work with my current IPython session.
Sorry, then how do you break out of that to get back to writing Python?
How do you break that? You basically, your cell is your, when you have a percent, just this snippet of code. After the end of your cell, you're back into Python thing. So if you want to do another R things, you have to use R explicitly. So basically, this things goes from the end of this line to the end of the cell is non-valid Python. This is something which is extremely useful. We won't go into the deep detail here. We have several talks online that speak about that. And you can define your own magics like that. We have people that have SQL magic if they want to make SQL query. There are people that have their own templating language. If you have some specific DSL code you want to have in your analysis, if for example, you want to inline some C code, you can here. So this one should work. I haven't written C in a long time, but you can do something like %% CFFI with a package and have a function in C which will be really fast, just inline in your code. And so if you have a bottleneck in your notebook, you can write Python or write C or write Rust or Julia, whatever, inside your notebook with the right extension, and it will just work. So just remember that usually %% something after it's not Python. In this specific case, it is Python because we decided that it's not Python, but it's Python. But here we are. And one of the things that you saw this morning is file, where you write a file and it will write it to disk. Actually, nowadays, it's better to use write file. For some reason, if you use %% file, it can screw up a few things. But that's just a detail. So extremely important. Do you still have my Fibonacci? Oh, let's go back. Use Control-Z or Command-Z to go back. You might see in tutorials often the normal Python prompt that looks something like this. Because that's what a normal Python prompt at a shell look like. And you can actually copy and paste that, and it should work. Like IPython will try to figure out, hey, I have an input prompt here. I will strip it for you. Yes, I have a question here. So you have to speak louder. I don't hear you from here.
If I define the decorator timing in a calling timing, and I do it the same timing, is it going to call my decorator timing or the IPython?
So if you define a timeit, will it use your timeit or the %% timeit? It will use a %%. If you want to use our %% timeit, you have to explicitly say %%. So it won't shadow your file. So if I do def timeit n equal test print n, and I do %% or even just yes, do a %% timeit, and let's do that to do only one loop. It prints test. So it's able to distinguish your timeit from my timeit because you have the %%. Does that make sense? Okay, great. And it also understands if you have something like that. So if you can copy and paste session from IPython. Ooh, it doesn't. Oh yes, I am missing something here. So if you copy and paste example from the internet, okay, if I copy and paste, it should work. I'm probably doing something wrong here. And another thing, if you are doing advanced usage, you can edit multiple places at once. So if I do this, I should be able to press colon once, and it still doesn't work. Okay, I don't know why. Here it works. Anyway, one thing which is really important is errors. Don't be scared of errors in Python. Errors are the most useful things, except Python makes them red and big and scary. But errors are your friend. So if I defined, let's remove this, it's starting to annoy me. Add a few cells below by pressing B and define f of x that return 1 over x minus 1. So of course you can see where I'm going here. I will do a division by 0, right? And I do fx of y that return f of y plus 1. So if I call g of 0, I get a 0 division error. You see, it's big, it's red, it's scary. It's not. It's basically telling you each step of the thing it did, when, how, and it gives you some extra hints. And if you want even more scarier things, you can make the traceback bigger and scarier, and it's actually even more useful. So to do that, you can do X mode. So X mode is a magic that will toggle between extremely short syntax errors, extremely short error message with almost no information, normal error message, and long error message with a lot of value. So you have plain, verbose, and context. So you can do question mark again. And it tells you, hey, you can use plain, context, and verbose. So let's try to use plain and do that. It should be slightly smaller. It's slightly smaller, it has slightly less color. But it's not really useful. And if I do verbose, and I rerun this one, you see that now I have a lot of things, and it tells me now, okay, G is this global function, and here in these specific things, Y is equal to 0, and in this specific area, X is equal to 1, and then you have the illumination when you have 20,000 hundred of line of things. Oh, here X is 1, so X minus 1 is 0, so yes, I am dividing by 0. And one other thing which is extremely useful, which is hard to get used to, but you should think about, is when you have a crash like that, instead of rerunning your code by putting print statement everywhere, which is not always possible because you don't always control the underlying library, we allow you to do post-crash debugging. So just after you got a trace back, don't run anything else. Use debug. Oops, I need to put a D. And if you put debug, you get dropped into IPDB, which is the IPython debugger, which is a small wrapper around a normal debugger. And this debugger allows you to move through the errors and see what happened. We won't go into the exact detail. So here you can press help and it tells you what the different commands are. And I can do something like list with a bang in front and it will, oops. No, just list without a bang in front, and it will tell me where I am. And when I am here, I can look at the value of things. So I can look what was the value of things at this point when I was in F. X was 1. Why was X 1? I will go to the step above that. I will go up 1 frame, and you can see that now I'm in G. And in G, I can say, what was the value of Y? And Y was 0. So debugging is extremely useful. Here, your kernel is blocked. You can only debug. You cannot do anything else. But really, you have to understand that debugging is scary, but it will be the most powerful tool that can be at your fingertip. And we make that easy. You don't have to prepare debugging before. We can do debugging after the fact with debug. And I had a bug here. The thing is saved, but I was supposed to press exit here to exit. I don't know why it did that. I have to interrupt my kernel and do exit. And now my kernel is not busy anymore. I see that my kernel is busy either because here in front, instead of the number, you have a star, which means this result is pending. And because the circle here is black. When the circle is black, your process at compute is actually doing some computation or waiting for some input. So if nothing happened, look at this dot and look at the number in front here and see whether you have a star or a black dot. It might be because your kernel is busy or something got locked or you have an infinite loop. And then you might want to do kernel and interrupt. OK. So let's go now to plotting. Let's make a Markdown cell. I know my keyboard shortcut. I know that I can change the type of a cell from code cell with a prompt number to Markdown cell with my keyboard shortcut. I'll let you look at your help menu and see how to do that. Hint, it's just M for Markdown. And I will say graphs in the notebook. OK. And so we provide a magic that allow one of the main plotting library of Python to display graph inline. That's one of the power of the web. With the web, you can actually have inline video, inline images, inline sound, which means that you can have your object that's just literally your object can be a sound, and it can be displayed as MP3, and you can press on play and hear it. If you're interested, if you've seen the colliding of the two black holes recently that was been discovered by LEGO, you can go online. They have published a notebook. You can click on a button which is called Launch Binder. We won't see what binder is. And it drops you in front of a live notebook. And you can literally, in a notebook, listen to the sound of two black holes colliding. It's quite amazing. And what we can do is use a magic which is called matplotlib and say inline. So inline means I want my figures to be inline in my notebook. And now you can do your normal Python computing, like import numpy as u. My spacebar is starting to be bad. As np import matplotlib.pyplot as plt. Now I can now do plt dot plot. No, let's do x and y. Let's do x equal np dot arrange. I want an array from 0 to 10 by step of 0.1. This is roughly like a list, except it's slightly more efficient. And y equal numpy dot sign of x. And I can plot x and y. And I should get something which is nice and inline here. And so you have your graph directly inline, which means that if you save your document, even if your process that runs the computation dies and your document is saved, you still have at least the graph of your result and some of your result available, which is one of the main advantage of that. And if ever you're using parallel computing or you have issues and you want to debug a notebook, there is something which is a little bit advanced, but I will show that to you now. You can use something which is called Connect Info. And Connect Info will give you all the information necessary to connect to the same process which is running your code from another thing that understands the Jupyter protocol. So here I should be able to do IPython app -- existing. That should be enough. I will just demo that it works. Here, let's do, how do I just do something like prompting on that to you. Just want to get rid of my prompt. Prompt equal that. Okay, great. Clear. I should be able to do IPython console -- existing. Oof. That's what's happening when you're developing the notebook. IPython qt console -- existing. Okay, so here you see that I'm directly starting at number 63. So let's get just a few seconds to my notebook. Let's define EO. Let's just first check. Is this me? Undefined. I'm going back to my notebook. Is this me equal true? Oh. Is this me equal true? And get back here. Is this me equal true? So I have two processes, two different applications that are talking to the same process which is doing computation, which can be extremely useful for debugging, or if you want to have some computation which is accessed by something else. We won't go into the detail about that, but it's quite useful. Okay, do you have any questions? So if you don't have any questions, it's because I haven't been clear. Okay, so I will just check that I didn't forget much by going into IPython behind plain Python, which was what I was supposed to follow roughly. So here is basically everything I said, which is said again, getting help, collections, underscore. So all of that, I'll go back through everything we said, and should be fine. So here, this should work. Yes, this works. So I probably forgot the space here. And so if you copy and paste something from a normal IPython session, like IPython, def f of a return 1, you can directly copy and paste that into a notebook and it will work. Error displays, plotting in the notebook. This is a slightly more advanced example that shows you how to create a figure and keep a reference on the figures and change how it works.
Can people stop execution if they're stuck in a loop?
Oh, how to stop? So there is a question how to stop execution if you're stuck in a loop. If the loop is Python, you can do kernel interrupt. And interrupt will try to send a, like if you're a terminal person, it will send a control C to the process. If you're in a C loop, you have no way to do that because the process will not respond. You have to access your, on Mac, it's activity monitor. And you have to find the PID of the process and kill it. But this is if it's a C loop, like if you're stuck in a NumPy loop or if you have your custom C function. Otherwise, I should be able to do that for I in range. Forgot the I, do nothing. I should be able to interrupt. And it's trying to interrupt the kernel as you see here, and it did interrupt the kernel, or maybe not fast enough. Yeah, I'm not fast enough, and I don't want to do a while loop. I'm scared. While true, let's do import time, and let's do time dot sleep 1 and print if you dare. Okay, so it did interrupt the while loop, and now I can actually try to debug that as I showed you before, and I have nothing to inspect, so I will exit. So let's get just if you want to know more about Markdown, there is this notebook which should be just next to the link I gave you in the schedule note that tell you more about what you can do with Markdown, how you can do lists, sublists, bold, how you can quote, how you can make headings, actually have some code which is not executable, math, tables, headers, and if you're using this carefully enough, you can convert your notebook directly to a PDF through the use of LaTeX, and everything should work fine. And you can also embed directly images or even videos in your notebook. And your objects that usually at the command line when you print an object can actually have rich representation. You saw that with the figures. Figures cannot be, hey, this is a plot which has address 0x0911FGZ6. It can actually display a nice video. And also, notebooks files are not plain text files; they are JSON files. Are human, we won't say readable, they are human debuggable. So if you have a notebook which is weird and you want to convert to a Python file, we are providing tools to do it. First, when you have a notebook, you can download it as a PY file here, or as HTML, as Markdown, as PDF. I'm adventurous, I will try to convert it to PDF on the fly. You need to have, that doesn't work, because you need to have the whole LaTeX stack installed. But you can download it as Python file. And notebooks are quite easy to manipulate on your own. So wait, what is notebook basic? And so notebooks are JSON file, and we provide APIs to poke around the JSON file. So here we are in a notebook, and we can basically try to look at the internal data structure. And so we are going to read ourselves. And so these things you haven't seen with, I think, this morning. This is called a context manager, which is extremely useful in Python. If you're from the C or Fortran background, you know that when you open a file, you have to close it. Whatever happens, you have to close it, otherwise you will leak file descriptors. And usually what with statements are called context manager. They ensure that when you do something with this object, when you exit this block of code, something else happened. Whether there is an error or there is not, the thing will happen. So here, what this with does, it is open the file, then I can do whatever I want with the file, and when I'm not anymore in the with, it will close the file, which is extremely useful if you're manipulating database or things like that. You want to start a transaction and a transaction. You want to log something. You will see that a lot in Python. It's called context manager. It's with, usually you will hear that it's Pythonic versus it's not Pythonic. It's because Python, we have a lot of guidelines. Nothing is strict in Python. The common saying is that we are all consenting adults here. We can do whatever we want. But it's not because you can do something that you should do it. And if someone tells you in Python that your code is clever, it might not be a compliment. It might be because it's too clever. We prefer to do things the boring way so that it's easy to read. And one of the things that you might want to read is the Zen of Python, and it's an Easter egg. You can import this. This is a keyword which is often used in JavaScript and other words, which it's not a keyword in Python. And it will tell you a few things about what is the philosophy of Python. So beautiful is better than ugly, explicit is better than implicit. Simple is better than complex. And a lot of guidelines like that. The other one you will see a lot is PEP 8, will tell you where to put space, parentheses, how to go to the new line, should I put 4 space and 2 space. It's a guide. It's not something which is strict because readability counts. And it's always better to break rules when you know you can break them. And the reason why we have a style guide is because for the human brain, when you have a consistency of style, it will be much easier for you to understand. So we are not being annoying when you make pull requests on GitHub and people say, hey, can you put a space there? It's because it has been shown that having a consistency of style will make everyone read your code faster and find more bugs. Anyway, that was just a small interlude. So here we can read our own notebook, and the notebook is just Python data structures like dictionaries and lists. And so you can do whatever you want. You can look at cell 0 to 5, and you can see that you have each cell as a source. And so now that you've seen a bit things, you might have seen people using list comprehension. You can do C source for C in. And we see Jupyter Notebook Basic project directory. And if we look here, we see that it's actually the same, right? And I can change here. I can do 2. I can save my notebook. I can rerun these 2 things, and here I have Notebook Basic 2. So if you want to create Notebook programmatically, if you want to change Notebook programmatically, you can do that on your own. You don't have to be stuck with Notebook. And we provide some options to directly convert notebooks. And I'm out of time. I don't remember at what time I started, so I will leave the rest to Josh now, if you have any questions. Oh, yes. Where are they already? I forgot. Exercise. Is it this one? So you have just a few exercises to see if you can learn to use a notebook and see if you remember what I've told you. And we can get something to drink.